of Way of Life podcast. For those of you who are not normally here or you're kind of visiting Wynnum Baptist for the first time, this isn't what we do every single week. We try to do this about once a month. So Way of Life, we actually believe that the way that you pick in life actually really matters. It truly matters. And we invite special guests like we've got today from all different kinds of fields to talk about different topics. So we can wrestle with life's biggest topics and have an open conversation about that. So today we've got the honor and privilege of having Luke Barnes with us. So let's give him a little hand. Hopefully he can see you as well, just so you guys know. Yeah. Let's give him a hand. So I'm going to give him a little bit of a bio. So Luke Barnes is a lecturer at Western Sydney University with a PhD at the University of Cambridge. He has published papers in the fields of galaxy formation and the fine-tuning of the universe for life. He is the author of A Fortunate Universe, Life in a Finely Tuned Cosmos, and the Cosmic Revolutionaries Handbook, or otherwise known as How to Beat the Big Bang. He has also published papers in the philosophy of science, and regularly engages in public outreach through public speaking, articles in the popular press, and social media. Luke, it's really awesome to have you on the podcast. How are you going today?
I'm doing very well. Thanks for having me. Thanks for coming out.
No, thank you for coming on. I'm pretty eager to talk. This is a huge topic, so I'm gonna jump in if that's perfectly fine with you. A little side note for our audience, whether you're in person or online, start formulating some questions that you might have for him, because we actually do have a Q&A, and the Slido, which is the website that we use, should come up behind us here. So this topic tonight, I was just saying this to you just beforehand, but it's probably up there as one of the most common topics that I get asked about from youth and young adults in particular, in terms of like, how do we navigate life with with God and the universe, and science? How do they compete? Can they work together? And all these different kind of things. And how do we sit on how old the Earth is? And how do we sit on the origins and how old everything is and the existence of God? So I wanted to kind of start off by talking about one of your books a little bit, or at least the topic of it. And you've got that behind you, which is awesome. So the fine-tuning of the universe. And before we get into that, I was wondering if you might kind of take us through, what does it even mean? What does it mean by the fine-tuning of the universe? What is meant by that?
So it's something that scientists sort of accidentally discovered about 40-ish, maybe plus years ago. So what it is when we try and describe the world around us as scientists, when you get down to the most basic stuff for the universe, atoms and the particles they're made of and all that sort of stuff, you try and write down descriptions of those that actually fit the world around us. Now, the language for that is obviously mathematics, but there won't be any maths in this presentation, so everyone can chill out. As part of that, as we put all the pieces together, we find that what we need in the sort of best laws of nature that we have, as well as all the other maths, is just a bunch of pure numbers that, there's just a value there. There are some properties of the universe that we can't predict. We just have to measure, and we have to put them into our description rather than sort of getting them out of it somehow. So, for example, you might remember from high school chemistry, or just from whatever, the picture of the atom where there's the thing at the middle and then the thing going around the outside. The thing going around the outside is an electron. For those playing along at home. And if you ask how heavy is the electron, it's obviously an extremely small number in, grams, but we can measure that number, but it's one of these fundamental constants. It's just something that describes the way the universe is, that at the moment we don't have any sort of deeper explanation for. What was noticed about 40 years ago was, okay, well, there's these numbers. We don't know why they are what they are. Well, what if they had been different? What happens in the universe if we hypothetically change the values of these numbers? There's about 31 of them in total.
Yeah.
And what was discovered was, quite alarming. You don't just get sort of a slightly different picture of our universe. You don't get sort of, there's a Star Wars universe and a Star Trek universe and all that sort of stuff. Overwhelmingly, if you start messing around with these numbers, changing their values, and then asking what happens in the universe, the answer is not very much. You end up just sort of ruining the universe for really any form of anything complex, anything that can stick to anything else and make something interesting. Suddenly you've got a universe where that sort of stuff literally can't happen. And so this is called the fine-tuning universe. It's really for complexity, I guess, but for life is the most sort of interesting bit of complex thing in the universe as far as we're concerned.
Yeah, okay, so forgive my not scientific brain, but would that be things like gravity and stuff like that you're talking about, like the kind of the fine-tuning of all these different elements of the universe?
Yeah, so for example, you can group them in a couple of cases. There's the stuff the universe is made of. There's the stuff that the universe is made of, which is the electrons, the other particles, up and down, quarks if you're playing at home, all that stuff. There's the stuff that moves that stuff around, the fundamental forces in the universe. Gravity is one of those, along with electromagnetism, the strong nuclear force and the weak nuclear force, so there's those four. As well as that, there's also a set of numbers that tell us how our universe sort of started off. So what was how much stuff there was in it, how fast it was expanding, how lumpy it was. There's a sort of basic set of numbers that describes all of that stuff as well. So these are the numbers.
Yeah, okay. So I'm intrigued to kind of hear some of your, the research that you did. What were some of the coolest things and most compelling and interesting things when you look at the fine-tuning of the universe in order for us to even live, for life to be in this earth, in this universe? What were some of those for you that you found deeply compelling?
So there's a couple of interesting things. One is that most of this field started in the scientific literature before anyone sort of in philosophy or apologetics or whatever anything else sort of noticed what was going on in the early 1980s. Another interesting thing is it's not really about anything as specific as our universe. It's not like, you change one of these numbers and all the grass turns purple and I don't like that. So that's, no. You change these numbers and nothing sticks to anything else in the universe, right? Your entire periodic table falls apart and there's no chemistry and nothing will happen to anything else. There's a number of cases that have been sort of investigated. One of the interesting things that I've done in my research with some colleagues is the way that we study how galaxies form in our universe, because it's quite a complicated problem, is via supercomputer simulations. So basically you set up, if you think of video games, like all the physics inside the video game and then it plays out. Now in that case there's someone using a controller, but you can think of a game that just sort of played itself. We can write computer code that will try to, as best it can, simulate the way stuff works in the universe. So particles will pull on each other because of gravity, and if those things get dense enough, other things will happen in the universe. We can use those to try to understand how galaxies form in the first place. What I did with a number of colleagues who, from a variety of fields, was to take one of these codes, supercomputer codes, and start changing the numbers. Whereas everyone else is trying to work out how our universe works, we wanted to know what happens if you start, fiddling with these dials. And it's not an easy thing to do. There's one particular number that we focused on, which we can talk about a bit if you like, called the Cosmological Constant. But it was a very interesting illustration, and in fact, it's not just an illustration, but a sort of in-depth scientific investigation as to what exactly happens in the universe when you change this number. This number is basically a form of anti-gravity. As you turn it up, everything in the universe gets too far away from everything else. So rather than having nice galaxies that form, you eventually just sort of blow the universe to bits.
Wow.
And so you don't get anything interesting. And so it's kind of fascinating that no one saw this coming, and the people who sort of discovered it didn't know it was coming. No one went looking for it, but it's remarkably easy to ruin the universe.
Yeah, wow. So, like, how fine-tuned are we talking? Like, how much would you have to change? Like, give us a variable in some sort of situation. Like, I've heard even, like, the distance we are from the sun and the moon and things like that, and how that can change life on Earth, or where it'd be way too cold or way too hot for life to change. Like, have you got any specific examples of where you could change that minutely and it would kind of change everything?
So the distance from the Earth to the sun isn't one of the fundamental constants. So we can think about what would happen if it was different.
Yeah.
What draws me to the fundamental constants is that they are as deep as science goes at the moment. So if we're doing like a stock take of where are we in science, where's the sort of bottom level where we can sort of, where we can pretend that things are, ultimate laws with no deeper explanation, where are we at with those? That leads us to the fundamental constants. The thing about the distance from the Earth to the sun is, yes, if it was too close, it would boil. If we're too far away, we'd freeze. But we now know that there's roughly, roughly one planet per star in the universe, at least. We know that from sort of direct observations. We can, we've discovered planets going around other stars, and so there's a lot of chances for the universe to get that right. To get the distance from a planet to a star right. Now, you don't just have to get the distance right. There's a whole bunch of other things you need to do, which makes it kind of interesting. What's good about the fundamental constants is if you want to start saying, maybe there's other chances out there, you're really talking about other universes, and then you're off into science fiction. You're not just talking about other planets around other stars, which we have seen. You have to start talking about other universes in what's called the multiverse, which is... obviously, is part of Spider-Man these days, but is also an idea that has been put out to explain this fine-tuning.
Yeah, okay. Well, what, I guess I'll pick on it.
You asked for a number. Yeah. Sorry. Classic academic didn't answer the question. Do you want a number?
Yeah, like, it'd just be so intriguing to hear how fine-tuned things really are, and I'm just after some cool examples that you found in your research.
Look, there's a lot of technical detail if you really want to jump into it. I've got papers on that. But the number I mentioned, the cosmological constant, famously, there's a huge range relative to the value in our universe where you could have, you can have this number, you can have that number, you can have any number in between, go and order yourself a universe. In that range, if you want anything to stick to anything else, right, we're not talking about whether the grass is purple, but anything to stick to anything else, the fraction of that range that you have to hit as a universe maker is 1 part in a number that has about 90 digits in it. Whoa. So 1 part in 10 to the power of 90 at most. So with regards to the masses of the fundamental particles, like the mass of the electron, and there's 2 other fundamental particles that you're made of, the up quark and the down quark, if you're writing notes. I think the sort of probabilities of getting, again, particles where they will stick together at all is, again, a number that says 1 chance in about 10 to the power of 30. So a number with about 31 digits in it. So we're talking amazingly, small probabilities. It's not the case that just any old universe will make life or anything interesting.
Yeah, that's really interesting. So if you have enough knowledge on it, you mentioned that, for instance, the distance from us and the sun was one of the kind of little things in that equation, and there were many other things to kind of go along with it that would be needed to make life. What are some of those kind of other constants that we need that are quite finely tuned?
Right. So the numbers. So it's the masses of the fundamental particles and their properties, the forces that move things around, and then how our universe started off. Yeah. On the basis of all that, if we had, science and infinite brains and all that sort of stuff, we could then calculate the distance from a planet to its sun, or, the Earth. So that's not a fundamental parameter. Yeah. It's an interesting thing that we could change, but it's not fundamental. Yeah. So the interesting ones for me are of the fundamental parameters are, I just said the how heavy is the basic building blocks that we're made out of.
Yep.
So there's 3 numbers.
Yep.
The cosmological constants, another really, really fascinating one. How lumpy the early universe is. So if you go back in time, the universe, we can see light from the very early universe that looks very smooth. So the universe started off almost perfectly smooth, and then structure started to form as gravity pulled things together. You've got to get the amount of lumpiness right. Too much, and you make the lumpiest thing in the universe, which is a black hole. It's a weird way to think about it, but that's that. But if you don't make any lumps and bumps in the universe, then all you have is a very thin, boring hydrogen soup, and nothing interesting happens there either. So there's a nice range in the middle that you've got to get to. With the fundamental forces, again, actually gravity's sort of tied up in the cases I've said already, but you can sort of guess what's going to happen there. If it's too strong, black holes. If it's too weak, nothing sticks to anything else. The force of electromagnetism, so charged particles, electrons repel each other, protons attract electrons. That force is holding all of your atoms together, so it's rather important.
Yep.
It had better be about right. If it's too weak, you have... There's various problems there, actually. You can have it so stars themselves aren't actually stable. Anything big enough to ignite itself in a nuclear reaction is big enough to also blow itself apart. So that's a bad outcome. If it's too strong, you can actually destabilize atoms. So that's a bad thing. There's the forces that hold our nucleus together, the nucleus together, the strong nuclear force.
Yep.
The weak nuclear force, which is a source of instability. You better get that one right, or everything just sort of falls apart.
Yeah, wow.
So yeah, there's a bunch of different ways you can, and sort of very inventive ways you can totally ruin a universe.
That's really interesting. I find it so fascinating how I think and I'm going back to kind of more apologetic type things that I've seen, and how compelling I found that, of how fine-tuned our universe and even kind of our galaxy is, for us to even be alive, to be able to think and do everything like that. So I guess you do have a Christian background, and how do you think that this fine-tuning of the universe helps us kind of show that it's plausible that God is real?
So one of the things that's quite nice about it for a start is a lot of the science is pretty well nailed down. So you mentioned my book. It's co-written with a colleague of mine, Geraint Lewis, who's a professor of astrophysics at the University of Sydney. He's an atheist.
Yeah.
So this is a Christian and an atheist writing a book together. We basically agreed on all of the science, except for one footnote that you can go and find if you feel inclined. So in terms of the scientific basis for what I'm talking about, this isn't some weird crackpot theory. This is the sort of topic where a Christian and an atheist can get together, write a book about the science and basically agree on it, be able to give a bazillion references to the published scientific literature. And so that's, I think, extremely useful as a starting block here. We're not trying to fight, oodles and oodles and oodles of science. The way I think there's a number of ways you can think about this in relation to God and science. The one I quite like at the moment is I've been reading again Richard Dawkins' book, The Blind Watchmaker. Dawkins famously is an atheist and a biologist. He wrote a famous book called The Blind Watchmaker, 1980-something, 6 maybe. And in the first chapter of that, he lays out the way that he's going to show that modern biology shows that there's no need for a designer of the universe. And if you read carefully enough and slowly enough, there's a point in there where he quite explicitly takes a great big chunk of the problem and just sort of throws it over from biology, the study of life, to physics, the study of the stuff that we're all made out of in the universe and all that sort of stuff. And basically says, I'll take physics for granted. In particular, what he's taking for granted is that when we look deeper into the workings of the universe, we'll just find really simple things there that we can just take for granted, and we won't be tempted to sort of invoke a designer in the same way that if you look at a hummingbird flying, you're tempted to say, well, obviously someone thought very hard about how to put that thing together. And I think what fine-tuning shows is actually, no, you can't just take physics for granted. You can't just throw the problem over to physics and assume that it's solved. As we look at the deepest laws of the universe that we know of, we see exactly the sort of that the conditions that life needs are very rare, in the same way that Dawkins says if you take a whole bunch of cells and you throw them together at random, you'll never make anything that flies. And so that can't be the explanation for how there's birds around. Well, what we can do is throw a universe together at random in this way of let's pick these numbers and see what happens hypothetically.
Yeah.
And whereas Dawkins, I guess, was hoping that any old universe would do and biology could take over. What fine-tuning shows is that no, that's not the case.
Yeah.
It's not the case that any old universe will do.
Yeah. Okay. And how does it kind of affect your faith, knowing kind of these fine-tuning, the knowledge of the fine-tuned universe? On a personal note.
One of the things that's nice is, so I was a Christian before I learned any of this stuff.
Yeah.
So I'm not going to say, I was an atheist and that convinced me.
Yeah.
But one of the things that's nice is it sort of fits in. I can see how a Christian worldview makes sense of it. And then when I try, probably unsuccessfully, but I try to put myself in the shoes of an atheist, particularly one who's scientific, who thinks that naturalism is true, that is, that natural stuff is the only stuff, that nature is all there is. I think this would be hugely uncomfortable, to say the least, when I put myself in those shoes for a while. It would be hugely uncomfortable to have to look at not just what looks obviously like design in the natural world around us, but getting that same impression for very similar reasons down at the very bottom of nature as we know it. Must be extraordinarily uncomfortable. Whereas for me, the real game changer in a Christian worldview is that there's a reason for the way the universe is.
Yeah.
It's not that there's just a straight out cause or it's just random or whatever, but there's a reason why the universe is. And that is enough to sort of suddenly narrow our focus down of all the ways the universe could have been to the ones that a good creator might actually have a reason to create.
Yeah, it's really cool. I found that really encouraging, that kind of talking about this and researching this actually kind of makes it even more plausible that there was an infinite mind that was all powerful, that was spaceless, timeless, that could actually make this happen in the first place and fine-tune it so well so we could actually even be around in the first place and admire that, like you say. So I kind of I don't want to take up too much more time on that. And I didn't spend quite as much time on this book as I should have. And keep in mind, I'll need a basic kind of outline of this, but I kind of wanted to go down the line of your other book with like the Big Bang and that type of thing, and kind of hear a little bit of where you sit on that and why. So it is one of the kind of questions I get a lot inside and even outside of church, like people that I meet who are Christians or non-Christians, of how do you reconcile like the Big Bang with the Bible, and then as Christians, how do we navigate that? Is the Big Bang even a plausible kind of theory in the first place? Because it is a theory, hence the Big Bang theory. So huge topic, I know, but what is the Big Bang theory? And is it plausible?
Right, okay, so the second book is called The Cosmic Revolutionaries Handbook, again co-written with Geraint Lewis.
Yeah.
What it was just, so as a cosmologist, there's the thing I do for my job, as a physicist and cosmologist, but you occasionally get emails from people who are like, I've got it, I've solved the universe, do you want to know? Or they send you like a 600-page poorly typed manuscript.
Yeah.
Like their idea about how the universe works. So what we wanted to do in this book was just lay out what the theory actually is, and what the evidence for it is, so that if someone wants to then say, I've got a better idea, here's the evidence you've got to explain if you want to be better than the standard picture of the universe, known as the Big Bang theory. the theory itself is actually fairly simple. The idea is simply that in the past, the universe was hotter and denser.
Yeah.
And that's basically it. The universe on average is the same wherever we look. It's not that there's way more galaxies over on the left rather than over on the right. And then that's what the universe is laid out, in space at a particular time.
Yeah.
There's just stuff everywhere. And then in time, as we go backwards, it gets hotter and denser. Now, as a part of that, there's a bunch of predictions that actually come out of that when we put that into a framework of gravity, a theory of gravity, in this case, Einstein's theory of gravity.
Yeah.
And that's how the theory itself starts to take shape.
Yeah, okay. So how would you, I guess I'll just get straight to it, but how would you navigate kind of the Big Bang Theory as a Christian when reading Genesis 1?
Right, so what this book's specifically about is the scientific evidence, right? I mean, it's Geraint, my colleague again, so he's an atheist, he doesn't really care about all that stuff. So scientifically, what I would say is that the evidence for it is quite strong. It's as strong as we'd expect it to be if it was a decent scientific theory. The question then as a Christian is, what is the Bible as a whole, and Genesis in particular, trying to tell us about the history of the universe in terms of its the history of the physical universe as a whole? Now, obviously that's an enormous issue. It's one where I grew up as a young Earth creationist and have since sort of changed my mind on that. If you want to read more about that, there's an article I published with Premier Christianity. You can go and find that one. For me, what I think Genesis is trying to teach us is primarily sort of theological truths about God first and foremost, and then truths about us that are true of all of us. Yeah. Right. There's something in Adam which is in common with all of us, and it's that thing that it's trying to teach. Yeah. And so as I look at especially Genesis chapter 1, I see that it's trying to teach us that, first of all, there's no, what I love about Genesis chapter 1 is that actually it's a terrible story because there's no bad guy, there's no antagonist, there's no tension. There's no, I wonder whether God's going to get exactly what he wants on day 4. He's like, no, I'm going to do this, I'm going to do that, I'm going to do this. There's no, so if you read, there are other sort of creation stories from elsewhere, and they're always really exciting with dragons and stuff. Yeah. And Genesis then looks just amazingly simple, and that's kind of the point theologically. Yeah. There's a difference between the creator and the creation. Yeah. There's a God who has complete sovereign control over everything, and this world is the way that God wanted it. It's made for a good purpose. It's made in an orderly way. It's a world in which we have a place, and it's a world that is fundamentally, as God made it, it is good. Yeah. There's a good plan underneath there. Yeah. And so I think that's the sort of what it's trying to tell us. On top of that, I don't think it's then trying to teach us a specific time frame or for creation. You see some clues to this throughout Genesis. There's a number of reasons for this. So just a couple of them. It doesn't say, on day 3 in particular, it doesn't say, and then God made plants, but it says, let the earth produce plants on day 3. Now, unless you have a sort of magical picture where God makes an entire tree pop up in a day, I mean, that's a picture that's not obviously literally true, I would say. Right. And so, it's not meant to be. Yeah. So that's a clue that it's not meant to be. Right. In particular, because if you had that sort of magical tree growing in a day, the whole point of the whole story is that God is laying down the order of creation. Yeah. So he's not going to break his own rules, having immediately set them up. Yeah. There's even later on in Genesis, when Abraham was born, his own father was about 100 years old. But then it doesn't make any sense that when God says to Abraham that he and Sarah at 100 years are going to have a child, they're both then skeptical. Like literally, he's I think it's him or his father, but he has in the story, in the account there.
Yeah.
He has ancestors who were born in exactly that circumstance. So there's something going on there that a literal reading misses. There's some layer of the story there that's more than just the literal reading.
Yeah.
In terms of the time frames involved.
Yeah.
Obviously, the New Testament and Jesus in particular treats, Abraham and Adam as real people. So those are fixed points.
Yeah.
But the timescale for the history of the universe, I don't think Genesis tells us. But that's one opinion. There are all the opinions you could ever want to have out there.
Yeah, there are many opinions around this. I was meant to say this earlier, and part of why we do this podcast is just to wrestle with different ones, and wherever you land is where you land. What would you kind of do? And I'll be honest, like this is teaching me too, a lot of the time. But how do you so as part of like the Big Bang Theory and like evolution? Would you believe that we kind of went from species to species, like the part, like one little atom turned into this, and turned into a tadpole, and then turned into that, and that type of thing? Like, where does it sit on that, and how do you navigate that with the creation story?
So I do see an awful lot of creationists trying to run the Big Bang Theory and biological evolution into the same picture. They're very, very different.
Yeah.
The Big Bang Theory could be true, but Darwinian evolution doesn't work scientifically. Obviously, for Darwinian evolution to work, there's got to be long timescales, but other than that, there's not much connection with the Big Bang Theory. So I think we need to treat those two separately.
Absolutely, yeah.
For a start, in terms of if you're just trying to appraise the scientific evidence, the evidence as we lay out in the book for the Big Bang Theory is things like the way galaxies are moving away from us, the sort of background light we see in the universe, the abundances of the elements of the periodic table left over from the very early universe.
Yeah.
A couple of other sort of strands of evidence there.
Yeah.
Turning again to biological evolution, the question again is, what do you think Genesis and the Bible are trying to say? So if you ask people, as a Christian, how do you believe atomic theory, that electrons go around the nuclei of atoms? Like, no one thinks the Bible says anything about that. So fine, like, who cares?
Yeah.
So it's a question of just, do you think there is anything in Genesis, in the Bible as a whole, which would rule that method out as a way that God could create the universe that we see around us, including the life that we see around us? Now, that's a separate question from, is there good scientific evidence for biological evolution?
Right.
Now, go ask a biologist. I see problems, but I see a lot of explanatory power as well. It's just not my field, so I can give you my half-baked idea on that as well.
Yeah, absolutely.
I don't really care. I think if you don't think that Genesis is trying to teach us anything specific about the sort of physical processes that got us here, it's teaching us more about God and his relation to his creation, sort of for all time.
Yeah.
And I don't see much of a problem with biological evolution being the way that God, created the world we see around us, except for possibly the problem of animal pain and suffering. But that's a theological problem. So go ask your favorite theologian. Yeah,
for sure. No, sounds good. So I guess then with the Big Bang Theory, because I don't know, I'm going to look at it more from a biblical perspective, and perfectly fine if you want to move on to a different question. But like, even I've heard that even between verse 1 and like the other verses, if you wanted to treat it more as a scientific document, was that like in the beginning God created the heavens and the earth. And a lot of people have said that that's the Big Bang Theory. And then kind of later down the line is where kind of God shaped matter and creation into these different kind of things that we see today. And I was curious, kind of, what's your view on that side of things?
There's a worry here which I have seen before, and let me illustrate it with another passage. There's a passage in Ecclesiastes which says something along the lines of, all the water runs into the sea, and yet the sea is not full.
Yeah.
From the place where the waters, where the rivers began, there they return. Now that's obviously describing the water cycle, right?
Yeah.
Rivers into the sea, and then they get back to the top somehow. Now, I've heard some Christians try to claim that this is sort of miraculous, prophetic knowledge that science didn't know about till way later, and so this is a sort of scientific miracle revealed to us in the Bible so that we can know that it is real and accurate and from God.
Yeah.
The problem I have with that reasoning is that it kind of cuts off the branch that it's sitting on. The author of Ecclesiastes was trying to make a bigger point. If you read the book, he's just giving an example of, everything goes around in circles. It's a very, the guy's a bit depressed, to be honest, for most of the time. You know, the book of Ecclesiastes.
Book.
He's a bit grumpy, and anyway. He's trying to make the point that life goes in cycles. There's nothing new under the sun, is the sort of the thing you get from Ecclesiastes a whole lot. Yeah. So he uses the example of water just going around in a circle.
Yeah.
If his audience didn't know what he was talking about, if it's some scientific thing that we only actually understood what he meant, 400 years ago, 200 years ago, whatever, then he's actually a really terrible teacher, because he was trying to teach something, but he used an illustration for it, which none of his audience would understand, and no one would understand for a couple of thousand years.
That's a good point.
Maybe 2,000 years-ish. So if it meant something to his readers, they must have been able to understand it. But if they could understand it as an illustration of something else, they must have known the facts that he was referring to.
Yep.
And so it can't then be some sort of a miraculous fact from the future. So that whole approach there just sort of doesn't work.
Yeah.
If they didn't, you have to, as a part of that argument, say no one at the time knew this. But if no one knew that, then there's no point putting it in the Bible, because every single one of its original readers will be like, what?
Yeah.
It'd be like the author of Ecclesiastes going, everything goes around in circles, like electrons around an atom.
People
what the heck is this guy talking about?
Yeah.
I see that sort of problem with any approach to the Bible where no one understood what it meant until a scientific discovery in the last couple of 100 years cracked the case, and suddenly we understood what the author of Genesis, what Moses was going on about, or what Isaiah was going on about, or something like this. I just think it has to have a meaning to its original audience, because that's who it was written to.
Yeah.
It was written for everyone, but that's who it was written to.
Yeah.
The exception that's sort of there for this is when there's prophecy, can be sort of layers of fulfillment.
Yeah.
Jesus is like David, so there's something about David, and it sort of applies even more so to Jesus. But I can't see that has any relevance here in terms of scientific facts, that God sort of left these little, just completely baffled people for 2,000 years so that we could see something with our scientific eyes. That doesn't work. And so I'm resistant to any reading of Genesis that needs a modern scientific textbook in order to understand what Genesis means.
Yeah, that's really good. That's a really interesting way of looking at it, because that's what I've kind of always thought. I used to be like strict, like 6-day, 24 hours type thing, but then I kind of realized that it was not really a scientific document, as you say. God was actually trying to convey some sort of story to it. Do you think there's any kind of negative ways that you could take that, if that makes sense?
Well, I was just going to say, I'm not sure if this answers your question, but actually, the literal 24-hour, they prefer to say, the young Earth creationists say to say plain reading of Scripture. So I don't use literal here in a pejorative sense.
Yeah.
But that sort of literal, I'll use the word anyway because it is correct. A literal reading of Genesis actually avoids the problem I just described. If it just means exactly what we think it means, that wouldn't be something where you need then it's not that there's secret hidden layers of meaning that the original audience wouldn't have understood.
Yeah.
It just looks like it looks on the surface.
Yeah.
I think if you don't read Genesis that way, there has to be meaning there in the text, which is the way I interpret it. I don't interpret it literally.
Yeah.
But I think it's a meaning there that's available to its original readers.
Yeah.
And they wouldn't, the real lesson of the text is not what it appears on the surface to be saying literally.
Yeah.
So I don't know if that's the answer to your question.
Yeah, no, that's really good. Because it's handy, because probably where I'm trying to suss out, and I always try and make a practical note of this, is that when you're kind of talking to people that might have a differing view on this kind of thing, or they're talking about how do we reconcile the Bible, I find what you're saying right now quite helpful. It's not that we're actually putting any kind of, we're putting scripture down as if like, oh, okay, it was wrong and all this kind of stuff, but rather it was actually trying to convey almost a completely different message. It wasn't meant to be kind of scientifically read in modern eyes. It actually had an audience of its own, and it doesn't necessarily kind of negate or make Christianity or God not plausible. So, well, I'm fairly certain we're going to have a bunch of questions. So we're going to take a little 5-minute break, unless there was anything else you wanted to add. And then you guys can put your questions in, have a little stretch, and then we'll get to the questions.